We're going to spend some time here looking at calibration of manure application rates. If we recall, when we're trying to put the value of manure together, we need three pieces of information. We need to know how much is being applied, how concentrated it is, which is the manure analysis, and then what is crop available. So right now we're going to focus on how much. The procedures that we have for doing this are all illustrated in our manure application workbook. Towards the back there is a set of tables for illustrating the calibration process that we're going to go through here in just a minute. Okay, there are really three different methods we'll talk about today. The first method is where we know the capacity of the spreader. We have access to a set of scales on our farm for weighing the spreader full and empty, or in a liquid tanker, we know the gallon capacity. So either of those kind of situations would work with this method. For this method, we need to know the capacity of the spreader, the width of the spread pattern, or how far we move over in the field with each pass, and the distance that's traveled. And we can combine those three numbers into this formula and either produce gallons per acre or tons per acre. When calculating the application rate where the spreader capacity is known, we do need to get a distance of travel required for emptying the spreader. To do this, a simple trick is to measure the distance of travel of one or more wheel revolutions as you're moving through the field. For a tractor, the rear wheel, we may need to measure the distance of travel for a single revolution, or for this truck, maybe 3 or more revolutions would be appropriate. You can mark the beginning and the end of this with a flag and then measure that distance. From that point, we can easily count the number of wheel revolutions it takes us to empty the spreader. Those two factors, distance traveled for one or more wheel revolutions times the number of revolutions traveled, will get us the distance to travel for emptying the spreader. When calculating the application rate where the spreader capacity is unknown, we'll have to pull some tricks that will give us an approximation. One trick that we can use with dry manure is to lay out plastic sheets on the ground, preferably 22 square foot in area. We will lay those out in the path of the spreader, hold the corners down with rocks or bricks, spread over those plastic sheets, and then collect the manure that has fallen on those plastic sheets. Usually we can collect that manure into a 5-gallon bucket and bring it back to a scale to weigh. The weight of manure that fell on that plastic sheet then can be used to calculate an application rate. If we had used a 22 square foot area for those plastic sheets, then it's a very simple calculation where 1 pound of manure on the plastic sheet equals 1 ton per acre. If you've not used that particular size, there's a simple calculation that's detailed in the back of our manure application workbook. Now we're ready to plug those numbers that we've just calculated into this equation to give us tons per acre. So capacity times a factor of 22, divide that by the width or the distance we moved over with each pass, and distance traveled will give us that calculation. So we can do that here quickly. We've got 9,930 pounds times the 22, and we divide that by width, which is 14 feet, and the distance traveled 494, and I believe that comes up to roughly 31 ton per acre that we estimate we've spread today. We'll conclude with a few comments on calibration of irrigation systems and their application of manure or effluent from a lagoon. Of course, with pivots, we can get good uniform application and give credit to the nutrients. It's a little bit more difficult when we're using a big gun or a flood irrigation because of the lack of uniformity in application, but certainly for pivots, it's very appropriate to try to give credit to the nutrients in the manure we apply that way. Probably a couple methods that we could use. They're detailed in the back of the book, the Manure Application Workbook. But very quickly, if we know the application rate or the flow rate, there's a very simple calculation of combining that with the acres covered that could all be done just with a piece of paper and a calculator. If we don't know a flow rate through the pivot, we might use something like rain gauges. A number of those along the length of the pivot at various locations can give us a pretty good indication of the application rate, and that, combined with the manure analysis, can quickly convert to so many ton or pounds of nutrient per acre. So it is appropriate to do a calibration of pivots and other application equipment, and the procedures are fairly simple.